Hello, everyone. Welcome back. We're here to talk about offloading devices. How do we decide what workloads move to the edge? My name is Edward Wilford. I'm the Senior Principal Analyst for IoT Hardware with Omdia, and I'm here today with Keith Schaub. I have where everyone's from.
I'm from Advantest.
Keith Schaub from Advantest, Michael Wilkinson from Paragon, and we've got Brandon Strom from Blues Wireless. Okay. So, the first question, this is something that caused a little discussion beforehand just now. We're talking about moving workloads to the edge. What is the edge? And Michael, you have the most opinions on this, so you go first.
I have an opinion on edge. The edge is by definition the edge, the end, the end. That does not mean a big power cord and a UPS and an Intel processor. That means a sensor, some kind of measurement or actuator device at the edge that communicates to something that eventually gets to the cloud. So the edge is the sensor, a dog collar, a camera, a something, period.
All right, we're going to have a fight about this. So, I'm just kidding. So, my name's Keith Schaub. I'm representing Advantest, and we are a global test solution supplier. So, have you ever thought about the AI chips that are in your phones? Who makes sure that the AI chip is doing its job? So that's what we do. Our test equipment basically ensures that. So for us, all of this test equipment is all over the world, and it's isolated. It's not actually connected directly to the cloud, but customers want to utilize the data coming off of those chips to make decisions. So for us, it's at the point where the semiconductor is being tested physically. That's our edge. It's a little bit different than you.
So if I'm the tie-breaking vote, I'm going to agree with Michael here a little bit more. But no, I mean, I think it's a valid, there's a valid point and counterpoint here, but I tend to think of edge as really the same way. It's the actual sensing devices. It's the ultimate thing that you're looking to monitor and make some sort of determination based on what's actually happening on that device in real time. It's how I really look at the edge, is really everything on those physical end devices that you're trying to measure, monitor, actuate, whatever it might be.
Correct answer.
I think it's a nice way of saying is that, I mean, the edge is the thing that creates the data, and then everything else is more or less handling the data that the edge creates. So I think,
Yeah, absolutely.
I'm willing to, it would be nice if we had just one thing that was the edge, wasn't it? If we said the edge, we could all go, we know exactly what you mean, and it's not debating whether it's bleeding edge, cloud edge, network edge, device edge. I mean, there's if we had one edge, we said it's this, it's device endpoints. But I do think that there's a useful distinction to be made from here's the network, and here is the edge of that network. And we don't call it the edge, we need to call it something else. But I think it's that we don't want to lose that distinction. Well, I think there's a good idea, makes it strict terminology on it. From the other side, okay, so we're offloading things from the edges is the sensor, okay, it's the endpoint. From the cloud, what are we offloading from? How does the edge look like from the cloud perspective? I want to weigh in on that first. What are we offloading from the cloud and why?
Okay, so I'm going to stick to the semiconductor market. So we test chips when they come out of the fabs, from as soon as they come out of the fabs, all the way through package and assembly, all the way through system level test. And if you think about a mobile phone, the mobile phone chip starts on the wafer, and then it gets packaged, and then it eventually gets on a board. All of those are different test insertions, and all of those generate data. So there are different use cases where that data needs to be used right then and there while it's being tested, versus that data can be collected and used later on, let's say several days or even weeks later. So those are, that's sort of the delineating line for how we look at cloud versus edge. The product is traveling through its product test lifecycle, and when it's being tested, maybe we need to combine some data to decide what to do with that chip. Do we throw it away? Do we do more testing on it because it's a marginal device, or is it so good that we can skip tests? So those sort of decisions you can only make live while the device is being tested. But there are other ones when we talk about heterogeneous chiplets, where you want to combine different chiplets from different vendors. Well, you don't need to make that decision live. That data can all be collected in the cloud, can be processed and analyzed, and then later on in the assembly process, you can go grab that data and then make the decision on which chiplets should be combined and how they should be combined.
So yeah, just to add to that, I think when I look at the question of how you offload, what you offload from the cloud into the edge or on devices, I like to say there's really 3 qualities of things that we look for. And my company makes cellular IoT modules, and so we work with a lot of industrial providers looking at monitoring machines on floors, working with the real-time data. And the 3 things that I tend to observe that we want to offload from the cloud are data where you're worried about volume of data, latency of what's being detected, or privacy. And in any one of those cases, it really makes a lot of sense to do everything we can to make decisions closer to where that data is actually being collected. If you're doing something in the holy grail of IoT solutions of anomaly detection, and you're measuring accelerometer data in real time, there's a very serious cost, both monetarily and in latency and the time to do something in the cloud if you're streaming that data in real time and then waiting for some sort of prediction to come back. Not to mention the fact that if your network goes offline, now you have no intelligence in your actual local installation. So if you have the ability to read that data, make a decision, and then the thing you send to the cloud is the result, the inference, the prediction that's made, you get the same value from a monitoring perspective, but you save yourself in bandwidth, cost, and time to actually make a decision.
So everything's about cost. Battery cost, dollar cost, something cost. And so making decisions at the edge or in the cloud, you have to think about the cost of battery life. If you've got the edge and computing power at the edge where you may not have a big processor to do a bunch of work, versus the cellular cost or Wi-Fi cost or any kind of bandwidth cost to get that data up to a gateway or to the cloud, and then the cost of the server at the far end, how much it costs to A, store the data, B, process that data. Usually that's lower cost when it gets finally up to the server from down on the edge, but the problem is getting it up there through cellular, whatever, may be more costly, or through LoRa radios, maybe not possible in a low bandwidth radio like LoRa to send a whole lot of data. We were just talking about that before we started. Yeah. And so you may have to make some quick decisions locally, some ML there, and then pipe the data up to the cloud if you've got a questionable answer, and then let the cloud do the rest of the computing.
So I want to add one. I want to add one more thing to what Greg and Brandon just said. Think about autonomous cars. So we test all the chips that go into Teslas and stuff like that. The cameras are making inferences and using that information to make a decision on how to steer, for example. That's not something that you want to send to the cloud that's going to take 100, 200 milliseconds to give you an answer. So there are specific use cases that force you to actually do the inferencing at the edge, and of course cost. In our industry, product is being tested. If you're waiting for the answer to come back, then someone's paying for the use of that machinery. In the car's example, of course, maybe you hit a tree and somebody died. So you don't want to have that. You don't want that to have happen. But for us, it's about cost, because if we send something to the cloud is highly unreliable in its latency. So by the time the answer comes back, we've already wasted the money that we would have saved from the inference.
So I mean, it's nice to move on to use cases, and let's talk about that a bit more. What use cases do you see moving from cloud to edge, or do you think are there or should move from cloud to edge? Anyone have any examples that they want to discuss?
I think a few that I am seeing and that we're seeing, one is machine vision. I mean, that one happens a ton. Privacy is obviously the bigger thing there. There are a lot of great vision cloud services out there, but the reality is that even if the hyperscalers have cloud services that are great for machine vision, I think Azure ML even has a service for doing emotion detection on faces. And that's nice. They don't keep the photos, but you still are transmitting that data over the internet and it can potentially be compromised. But there's a lot of use cases in factories where you're doing, there's a company that we work with that does safety monitoring in facilities, right? And if they can actually do ML on their devices, and in many cases this is on single board computer class devices, but what they're doing is effectively monitoring a video stream as it comes across for compliance, for safety, to make sure that they can detect accidents when they happen. And they're doing so in a way that none of that raw feed ever gets streamed up to the cloud. It never goes beyond the individual, either the box that it's on or the network gateway that sits in the facility or something along those lines. It never goes beyond that point, so the privacy of the workers is actually protected in that case. But the metrics, the data that you're getting about accidents, about out of compliance behavior, things like that, do tend to make their way up to a remote monitoring service if that needs to happen. But that to me is, I think, a very powerful use case that we're seeing a ton. That tends to be an easy one because when it comes to using pre-trained models, in the vision space, there's a lot more there than there is with anything else. When we're working in an industrial case, if you're doing ML on a machine, on an elevator, on something on a shop floor, there isn't a pre-trained model for your machine. So you do have to go through that dance of, you have to do that data collection, you have to go through that model training exercise yourself. And there are a lot of great cloud services out there that facilitate that, even if they're ultimately trying to facilitate the creation of a model that can run on a microcontroller or SBC class device. And so we see a lot of those kinds of things.
So I'm a distributed guy versus a centralized guy. So because I believe there can always be a problem between me and the server. You can just think about it from your PC perspective. Most of the time you can log on, get to the office, you can get to the cloud, you can surf the web. But just every now and then you're in the wrong hotel room, you're in the wrong, down in the subway or whatever, you don't have access. And so you really like to have that file on your PC. Well, the same is true with the edge and devices. So I take the approach, and our team does when we develop new products, is to have all the decisions made at the device level. I just make the assumption that 100% is made right there. Now, it's not practical, especially with a lot of the computer vision stuff we do. So we say, okay, what can we do locally? And then because of that cost I mentioned earlier about cellular cost or other communication costs, battery life, et cetera, and then product cost if you got a higher processor and stuff, what can we then offload? So I start with distributed and then push it upward. And it doesn't have to always go all the way to the cloud. You know, if we're in a factory environment and we're doing LoRa radios, well, we eventually have got to get that to, say, cellular or Ethernet or something. So at that gateway, maybe that's where I do a lot of the computing, because that's a place I can plug into a power cord into a wall and get juice and do more computing and not have to go all the way to the cloud and save on that cost. So sometimes there's middle ground for making those decisions. But I start from the end edge device first and then push decisions up only when it makes sense.
Not much to add on that. I would add, or I would say the two things that we look at as key drivers or key delineators of should it go to the cloud or should it go to the edge. And we use both, by the way, because you have to use both. But the first is latency. I make the same assumption, actually. Most of our industrial applications need to happen right there at the edge. And so we make that assumption, and then if we can back off of that and put it into the cloud, that's great. The second is security. Security sometimes trumps the latency, because the models that we're dealing with, these are the semiconductor models that the chip manufacturers build about their products. And the data that's coming off of our testers is highly proprietary. So the last thing they want to do is risk pushing that data up to the cloud if they don't need to do that. So really, security and latency.
So following on a bit from that, what sort of enabling technology would make more of this offload simpler, easier, more approachable? So would it be more robust compute at the edge? Would it be, is it a power issue? Is it a bandwidth issue? Is it a software issue? What would enable more of this to happen?
So I'll answer from the bias. I'm a microcontroller guy, so my answer here is going to be that silicon is actually already moving in the right direction with a lot of this. I mean, you can buy Arduino class devices that have 2 megs of RAM, 2 megs of flash and a meg of RAM, and you can do a lot with an on-device machine learning model with that sort of case. But the reality is, as I mentioned earlier, with a lot of use cases, if you're working with accelerometer data, or you're working with some sort of environmental data, and you're starting from scratch on a net new machine in your facility, you still have to go through the process of data collection and model training. And so there's a growing number of services that I actually think are really great to facilitate this sort of thing. I'll give a pitch. I'm not paid by these guys, but Edge Impulse is one that we work with a lot and our customers work with a lot as well, that actually facilitates this process of taking your actual POC device with a connected accelerometer, streaming that data up to their cloud service, and then they facilitate the exercise of training the model, and then they build you a tuned model that you then deploy on the microcontroller itself, and it's trained on your data, your devices. And so you still need that cloud piece. I still am a strong believer that you need the cloud for model training. I know there's some work in that area. I'm not a believer in that yet, because I think the reality is that we need that compute infrastructure, and you need high volumes of data in order to facilitate that. So they work through that process of training with your devices, with your data, and then giving you something tuned for a microcontroller for the class of device that you're actually working with. And I think that's a powerful way to look at the dichotomy between the two.
Ditto.
I kind of want to say ditto, but so I'm going to take a little bit different response to this, or give a little bit response. What if we could automate and integrate security into the data? So it doesn't exist today, and there are all these companies here that provide security, and they obfuscate this, and they obfuscate that. But what if somehow all the data is actually open, but unless you have some sort of special key, you don't know what the data is? Then all of the security concerns would be built in, or would be handled, because the security is built into the infrastructure from scratch. I say that because we at Advantest, we spend an inordinate amount of our time and resources looking and building security into the entire infrastructure.
I think we should call that the collect, connect, and protect model, and I want you to credit me with that if you use it in any of your marketing. Okay.
Collect, connect, and protect. All right, you're hired.
It's pretty good. So I'm going to do one last general question. Then I'd like to get some questions from the audience after this. But let's say it's a year from now. Okay, we're all back here. Okay? We're looking back on 2023. What do you think is the story from your point of view on ML? And looking forward to what are you looking forward to for the next year and the years to come?
I think each year is just going to get better. I think we've been talking about AI and ML for 100 years, it seems like. But I think we've seen real-world examples of it working. I see our companies using ML more and stuff. So I think next year I'll be able to say, hey, almost every project we did this last year had some sort of ML component in the either in the edge or not too far away from the edge, and in this at the server level as well, in the cloud.
Yeah, I agree with that. I think that the incremental movement and that incremental forward progress is something that we're observing. I think there's also, a general industry awareness of how we move forward in the right. And I've been in this space a long time, and where we used to get questions from customers where they would come to us and say, hey, I want to buy ML from you guys. It's not something we sell. That there's an understanding that that is an iterative process to build something for yourself, for your solution. And then we've gotten past that place of understanding. I think there's some interesting advances in silicon that's actually tuned for running ML workloads. I think we'll really start to see some of that stuff come to market in 2023. It'll still be early days, still be very POC ready, but I'm actually really excited to see some of that with dual processors and co-processors that can run app code but offload some of that ML on devices, so you get even better performance from workloads running on those devices.
Yeah, they're talking both. So again, I'll go back to the semiconductor industry. To keep this simple, the biggest challenge that the entire industry has right now is power efficiency for AI and ML chips. So the whole industry right now is trying to figure out how to build more power efficient, high performance compute machine learning chips. Because the power that they give to our lives is so beneficial, but the energy cost is so high. So right now, just to move data around, it requires 1% of the world's energy output. But data, we know, is exponentially increasing. So next year, it will be 2%. The year after, it will be 4%. So in just 5 or 6 years, we're forecasted to be at around 50% of the entire world's energy just to move data. So that's why the entire industry is trying to fix this problem. So how do we fix it? Well, the current thinking is heterogeneous chiplets. And you've already seen that with AMD and NVIDIA and Intel. They're coming out with chiplets that you can break apart and you can put them together like Lego blocks. So next year, getting back to the answer, I guess what we should hope to see is Lego blocks from different companies that actually fit together very nicely so that we get high efficiency AI and ML.
So what I've heard, I think I've talked to 2 major manufacturers of MCUs who have both said that they don't anticipate a future where there's not ML incorporated in MCU, that it's simply going to be easier to put it in everything above us. So you're not going to put it on an M0 plus, but it's going to be M3, M4, that sort of level and up. It's just incorporate it, and then you can use it or not use it. But from a cost point of view, it's going to be so popular, so needed, that it's easy for them just to throw in everything. And I think that's a tremendous tipping point for ML. And if people have it, if you have it on an MCU, you'll find a reason to use it. I mean, compute's never going to go wasted, is it? Okay.